So in this video, we are going to solve problems from exercise 13.6, which belong to chapter number 13, surface areas and volumes. So in this exercise, we are going to, in fact, going to focus on the volume of the cylinders. So let's see what is question number 1. So the question reads, the circumference, okay, let me get it on the, yes. So the circumference of the base of a cylindrical vessel is 132 centimeter. So they're talking about the, let me highlight, they're talking about the circumference of the base of the cylindrical vessel is 132 centimeter and its height is 25 centimeter. So the height is 25 centimeter. How many liters of water can it hold? So 1000 centimeter cube is equal to 1 liter. That is the unit for conversion. So we know that if in a cylinder, okay, let's focus on this cylinder. There are two parameters that are needed to calculate the volume of the cylinder. One is the radius. So this can be its radius. I'm just going to mark here. Yes, so this is our radius r, okay, and one is the height. So if this is the center of the top circle and this is the center of the bottom circle, and if we connect these two centers, then that becomes our height. So let's use a different color. So this is our height. So I'm just going to say height h. So height h is given to us. Height h is equal to 25 centimeters, okay, and radius is not given to us. Radius we have to calculate. Okay, so let's read the information once again. Now the circumference of the base of a cylindrical vessel is 132 centimeter. So circumference of the base. Now what is the base of the cylinder? It is circular in shape. And what is the circumference of a circle? So let's write it down. Circumference of circle, okay, is equal to 2 pi r, okay. So we know this is a standard formula to calculate the circumference of circle, 2 pi r. However, they are saying the circumference is 132 centimeter. So I'm just going to write here 132 is equal to 2 pi r. And therefore, we get the value of r, which is the radius, that is equal to 132 the whole divided by 2 pi. This becomes the value of our r, which we will use to calculate the volume of this cylinder. Now let's come down. Yeah. So we have this value of r, which is this much centimeter. I have purposefully not solved the value of r. We'll solve it at the last step. First, we'll do the substitutions. So unit is very important. I'm just going to write here centimeter. This is r in centimeter. And we have height h is equal to 25 centimeter. Now, eventually we have to calculate the volume. How many liters of water can it hold? So let's come down here and let's write here volume. So volume of cylinder, we know the formula for calculating the volume of cylinder. It is equal to the area of the base. So what is the area of the base? Pi r square, because it's circle. So pi r square into the height. So pi r square h. Okay. Now let's substitute this. Okay. Let's substitute this value of r here and this value of h 25 centimeter here. So pi will remain as it is. Now r is 132 divided by 2 pi and the square of it, and into h is equal to 25. Okay. Now let's try to solve this mathematical expression. So pi into, I'm going to write 132 divided by 2 pi into, because it's a square, 132 divided by 2 pi into 25. Okay. Now let's see what can get cancelled out. So this pi and this pi get cancelled out, and 2, this will be 2. So 2 6 are 12, 2 6 are 12. Okay. And similarly this 2 and this 2 will be 66, and this pi will remain as it is. So pi can be written as 22 by 7. So let's go step by step, no need to do hurry. So this will be equal to, sorry, let's use the black color. Okay, now let's change the color. So this will be equal to 66 into 66 divided by pi into 25. Okay, and now let's substitute the value of pi. So pi will be 66 into 66 divided by 22 by 7, okay, and into this 25 as it is. Once again, this will be 22 into 3, okay. So eventually we get 66 into 3 into 7 into 25. This becomes our centimeter cube. The unit is very important. Without unit, it has no value. This number has no value. So this becomes the volume of our cylinder. So let's come up. Okay. So cylindrical vessel was there, which has this as circumference and this as height. How many liters of water it can hold? So 1000 centimeter cube is 1 liter. So let's use that now. So this becomes the volume of the cylinder in centimeter cube. Now in liters, so I'm going to change the color. So in liters, the volume is equal to, the volume will be, so it's basically going to be the 66 into 3 into 7 into 25, the whole divided by 1000. This will give us the volume in liters. So now the unit will change. Okay, from centimeter cube it is going to be liters. So I'm just going to write a capital L, that is equal to liters. Now once again let's try to simplify this mathematical expression. So we all know that this will divisible by 25. 25 4s 140. Now then we can divide this by 4. 4 into 10, and this will be 4. 4 into 1 is 4. Oh, this is not divisible by 4. Let's go by 2. So let's divide this by 2. So this will be 20, and if you divide this by 2, this will be 3 and 3, 33. Okay. So eventually we will get this is equal to 33 into 3 into 7 whole divided by 20. This is again in liters. So now we can simplify this. This is equal to 33 into 21, the whole divided by 20, and this will be in liters. So roughly, this 20 and this 21 will cancel each other, and it will be 33 liters. So we can always use a calculator to find the exact value, but I am going to skip that part. So this is approximately equal to 33 liters. Okay, it will be a little more than 33 liters. I think it will come about 34 or 35. Anyway, doesn't matter the accuracy. What matters is the steps we follow to come to this problem. To come to this answer. So 33 liters, approximately 33 liters is going to be the uh, capacity of this cylindrical vessel, okay, with this circumference and this height. So this is how you approach a problem. Quite simple and straightforward. The only thing was they had not given us the radius of the cylinder as it is, so we had to derive it from the circumference, and then it was a straightforward application of the volume of the cylinder. So this is how we solve problem number 1. Now let's erase all these things and go to the fourth problem. Okay, so all this is erased. Now we'll see the fourth problem in this video, and then we'll go to problem number 2 and 3. So once again, this is our this is our cylinder. We'll try to get it down here, and let's erase these things. Okay, so now let's zoom in and focus on problem number 4, which is also quite simple and straightforward problem. We have to just apply our formulas. So let's read what the problem is. If the lateral surface of the cylinder is this much and its height is this much, then find first the radius of its base, and then you have to find its volume. Instruction is use pi equal to 3.14. So once again, they have not given us the radius of the cylinder in a straightforward manner. They have rather given us the lateral surface area, from which we will calculate the radius of the cylinder. Once we know the radius and the height, then we calculate the volume. Kind of similar to the previous problem. I'm just going to mark the dimensions here. So this is our radius. Okay, so let me write here radius r, which is unknown, and then we have this height h. Okay, so this is our height. Height is given to us, so height h is actually equal to 5 centimeter. Okay, now the information that is given to us is the lateral surface area of the cylinder. We all know what is lateral surface area of the cylinder. The lateral surface area is nothing but this curved surface area. Okay, lateral surface area is another name for curved surface area. Note, it is just the simple curved surface area. It is not the total curved surface area. So that is an important point. So I'm going to write here lateral, okay, lateral surface area. Lateral surface area is equal to curved surface area. It's just two different names, okay, but it means the same thing. Is equal to curved surface area. And what is the curved surface area of the cylinder? What is the formula? It is this perimeter or circumference, that is 2 pi r, into the height h. Okay, so that is equal to 2 pi r h. This is the formula to calculate the curved surface area of a cylinder. However, the value is given to us. So this is the value 94.2. So we are just going to substitute this value here. So let's begin. So therefore, we are going to get 94 95.2 is equal to 2 pi r h. Now, we know the value of h. Here is the value of h, 5 centimeter. So let's do all the substitutions. Let's zoom in. Therefore, 94.2 is equal to 2 into, I'm going to keep the pi as it is, r into 5. H is equal to 5. So r is our unknown variable. So I'm just going to say therefore r is equal to 94.2 the whole divided by 2 pi phi. Okay, let me use a highlighter. So this 2 pi and phi, these numbers I have taken to the left hand side of the equation. So now this becomes the value of the r in centimeters. So I'm going to write here in centimeters. Now we want to explicitly find the value of r. It is mentioned in the question. Find the radius of his base, and this is the value of pi. So let's substitute it. So I'm going to zoom in now. This is equal to 94.2 the whole divided by 2 into 3.14 into 5. Okay, this whole centimeter. Now, so 5 into 2 is 10, so that's not a problem. This could be a multiple of this. So I think into 3. 4 3 are 12, 1 got 3 1s are 3, 4, 3, yes. So 3.14 into 3 gives us 94.2. So we are going to use that. So this will be 3. So that will be equal to 3 divided by, and 2 into 5 is going to be 10. So I'm just going to write a 3 by 10 centimeter. That is equal to 0.3 centimeter. So 0.3 centimeter becomes the value of the radius of this cylinder. So let's come here and substitute the value. Yes. So radius r is now equal to 0.3 centimeter. Okay. Now look at this cylinder. We have the height h, 5 centimeter. We have the radius r, which is 0.3 centimeter. And we have to calculate now its volume. So that's all. We just need the value of radius and height to calculate the volume of the cylinder. So let's come to this side so that we have space. Okay. So now it's quite simple and straightforward. The volume of cylinder is nothing but pi r square. What is pi r square? The area of this circular base, pi r square, into h. That will give us the volume of a cylinder. So pi r square into h. So let's substitute the values. Pi is 3.14 as they have said, into radius is 0.3 the whole square, into the height is 5. Okay, so this is going to be 3.14 and this is going to be 0.09 into 5. Okay, and this will be equal to, let's use a calculator to find the value. So this is equal to 1.413, unit is very important, centimeter cube. So this becomes the, in fact let's use a highlighter to box it. So this becomes the volume of the cylinder which was asked us. Okay, so we have to calculate the volume of the cylinder. This becomes the volume of the cylinder, and the radius is this thing. Again, let's use a highlighter. 0.3 is the radius of its base. So thus, once again, we have solved this problem. Lateral. So the radius of its base was not given to us in a straightforward manner. So we had to use a lateral surface, which is curved surface area. This formula to calculate the radius of the cylinder, and then eventually we knew the radius, we knew the height, and we calculated the volume of the cylinder. So that's it. Quite simple and straightforward problems. You have to be a little bit patient because the calculations can be tricky. They involve decimal numbers and all, but eventually the problem is quite simple and straightforward. That's it.